Okay, so I've been using my 4195 a lot these past few days slash weeks. Just wanted to share a few tips. First thing I did, well, one of the first things I did was these connectors because, well, they're N connectors, they're expensive, they don't last forever, and N cables are just so bulky, I don't use them, so I have these SMA jumpers that I have there. I'm not a huge fan of it. It's not working great, but it's fine. At least it gives me a bit of flexibility, and like these I can replace. It's not a problem, but I definitely didn't want to be plugging in and out the N cables. Now, they do make test sets that plug right into there, and you'd want to use them if you really care about your measurements, but they're super expensive, and often they use APC7 connectors, and wait till you see how expensive those are. So I'm just not using any of those test sets. Yeah, so these probe power connectors, they're fairly common on a lot of test equipment, but for some reason there is absolutely no standard part numbers for these. I don't think you can even get them direct from a Keysight now. Some people on mailing list found a similar enough connector that you can file down, and like the pin spacings work just about right. I'll leave a link to that. So that's what I used for a buffer amplifier, which is dangling precariously here on the edge of the desk. This is it's a clone of the HP3577 input circuit that gives you a high impedance input on one side, and it's just a buffer, a unity gain or roughly unity gain buffer, and 50 ohms out to the analyzer. It's really unfortunate that the 4195 doesn't have those high Z inputs. It's only 50 ohms, and I find myself often needing or wanting high impedance to measure things like noise on a power rail, or in this case I was sweeping audio circuits, where 50 ohms just really is not practical at all. When you're working at low frequencies, let's say start 1 hertz to stop, let's say 1 megahertz, like that, it's like fine, that's super fast. But then you notice the resolution bandwidth is 3K, which is way too wide for most work. So then you go and bring this down like that and say, oh, 100 hertz, and oh my gosh, your sweep time has just gone up to 5 minutes and 32 seconds. And with the RBW to 100 hertz, then the first bit from 1 hertz to roughly 3 times RBW, you're gonna have garbage data. Like if I start the sweep again, it's a bit of a problem, and that's super slow. So what I do is I go into this the sweep menu. I do into the resolution, number of points, and I bring this down to 101. Then what I do, well, sometimes what helps is setting the RBW to automatic, and that should select a resolution bandwidth appropriate for the center frequency. And you can find that. You can see what it's using if you go into it's a program sweep with a program table, and then okay, so it copied all the points, and you can see the frequency and the bandwidth it's using. And yeah, it's just awful. You can't really scroll with this nice dial they had for you, but no, you gotta scroll like a caveman. Anyway, yeah, of course, I'm starting at 1 hertz. There's rarely a need to go that low, so I try and keep the start frequency as high as I can. Let's say 10, or heck, even 30. It's not making a huge difference on the sweep time for some reason. Let's see if I go reduce the number of points here, 51 points. It's still very slow. What I noticed is that in spectrum mode it tends to be a lot slower. If I bring it back to network mode, then for these same settings it's claiming 30 seconds. If you're measuring networks, I'm usually paranoid, and I crank up the attenuators way up, and I use a fairly low signal until I know nothing's clipping. If there's no sweep active and you're overloading an input, you will not know. You need to have an active trace, so that's where it's helpful to have it on continuous, and make sure it goes through a full sweep. Sometimes at very low frequencies, it'll say overload on input R2 or whatever, and it's I don't know why it does that at low frequencies, but what I usually do is just change the sweep and set it a bit higher. Depending on your network measurement setup, whether you have a jig or, like me, if you're using off-the-shelf, like, oh my gosh, if you're using couplers like this and dividers, like discrete components, you want as little attenuation as possible to get as much signal as you can. That improves a lot the precision, and you'll be able to tell. I find the phase, like the blue trace, the phase is pretty sensitive to that. It'll show you, like, let me bring the scale. So on network, yeah, if you have too much attenuation on the reference port, then the yellow trace might be kind of okay, but then you end up with a situation where, well, let's see, let me just put this in manual. Like, see that that dot, it's moving up and down. So on a single trace, you won't notice, but that's actually measurement uncertainty, because, well, I have nothing connected right now. But you see that the phase is jumping all over the place, so it's pretty obvious. And that usually is helped by, like I said, less attenuation on the reference port and as much amplitude as you can on the source port, because more signal, less noise, this and that. One problem I have had with that little buffer amplifier that I showed earlier is there's a fair amount of a crosstalk between two channels. It's something I'm not sure yet how I'm going to fix, but there wasn't really any solutions except being aware of it and trying to work with strong signals as much as possible. I have a little measurement setup that's too ugly to show on camera. So there's two things going on. There's a lot of noise at lower frequencies, and it's kind of weird. But I have lots of attenuation on the reference, so let's try 0. Yeah, a bit better, but not that much. The other thing also is I have RBW at 300 Hertz, which means below 1 kilohertz. I can't trust any of this on the left. Let's try. It's getting better now. I don't understand this jump here. I did touch the cable, but it's still kind of weird. Oh yeah, it was probably just my fault. I also have lots of attenuation on the test port, so let's try and bring that down like that. Well, it's getting kind of better. What I've done once or twice, but it hasn't been super useful for me, but good to know anyway. In the trigger and the sweep menu, down here you can do a partial sweep. Let's say I wanted more details on that first section here without running an excruciating long sweep. You go into this one, partial sweep, and you're going to need your two markers here. So I can't remember which is which, but I think it's clever enough to figure that out. And then you select your area like this, and then store the range, then enable the partial sweep, and then I think, yeah, so it did just that. So you can bring the resolution bandwidth way down, and then refine parts of your trace. And if you're not happy with that, then you go back into partial sweep, you move your markers around, then store the range again, and oh yeah, see, it has these little arrows at the bottom to show you what it's going to sweep. Sometimes if you're measuring networks, or I think impedance, that's also pretty common, but let's say it's a network measurement, and that blue trace will sometimes ramp up, and then at the top it'll jump down and keep ramping up. That's simply, it's wrapping the values around. So you need to go into display. On the second page you have phase expand here, and that should fix the wraparound. Okay, here's an example of that phase wrapping around and how you fix it. Phase expand, and there we go. But then you need to go into B and then auto scale again. Okay, I want to talk about traces a bit. Let me just stop this triggering here. Yeah, I'm not aware of a way to stop a trace, an easy way. So if I was doing a super long trace and I'm not happy with the settings, and I don't, or sometimes I'm overwriting a trace that I wanted to keep. I just trigger the trace again, go into here, and bring it into single mode. So about traces, in network mode you're going to have the yellow and the blue traces. You can also, like if you're going to be comparing measurements, then you're going to want to do store AB into CD. You can enable these, so view C and D are the dimmed version of the yellow and blue. So if I do a second trace, well, it's going to be kind of hard to see, yeah, because I'm measuring nothing, but you can sort of tell there's a dimmed copy there. These letters, A, B, and C, D, you can, they call them registers, and they contain, it's probably closer to vectors, they contain all your measurement points. What you can do if you're, let's say you're measuring spectrum, like that. I got garbage on the blue trace, but you could use that for comparison, for comparing more than two traces. Like if you're not happy with just the A, B, and C, D, which you can swap with this, what you can do is clear this line, blue button, and let's say I want to copy this to the blue trace, the dimmed blue trace, that would be D. So D equals A, enter. And now if let's say I mess around with this, see, so I have that D trace there. So you can do math on these measurement vectors. It's going to be pretty convenient. If you want to change, like I was measuring low frequency signals where dBm, like 50 ohm referenced values doesn't really make sense. So what you need to go is go into format here and change your units to volts. And I'm not a huge fan of how it handles changing units and changing the scale. Like for instance, these traces stay in the same place despite that scaling, like reference is -10 volts and 10 volts per div. That doesn't make any sense. And if you go into scale ref and auto scale, it messes up everything again for you until you run another trace and goes way off screen. So you have to go into here again, and oh yeah, that makes more sense. Also, if I'm going to be working with voltage units, I like to go into display, then, oops, no, a scale ref, sorry. Scale, put it into log, and then same thing, like you can't, oh yeah, okay. Earlier it didn't work, I don't know, sometimes it's kind of finicky. I think it also depends on which traces you have enabled, like if I clear these two, well it shouldn't because it's doing A auto scale, not C. But anyway, there's a few things that I can't explain in there. For exporting these drawings, plotting this view, I do it over GPIB. Well, you don't have much of a choice. You could use that plotter that I think it's called the 7470 plotter emulator, and then I need to mess around with these settings and start the plot from here, then go watch it come in on your computer. I found that didn't work quite well for my combination of software and hardware. What works though, I'll show links to that. I got a script that gets a screen dump from this. What I haven't figured out yet is after you send GPIB commands, it flips to remote mode, and then you can't do anything, so you just have to press local, and then you can use the front panel again. Also, you can change that title up there, display second page comment, and the command is CMT with quotes, and there we go, boom. Markers are pretty standard. You can find the maximum with, let's see, for B, you find the maximum here. There's some tricks you can do to find, let's say you have a bandpass filter and you want the bandwidth. You can, well, you can read the manual because I don't remember how to do it, and there's a few useful examples of doing that. So for measuring impedance, the test set that they recommend with it starts at 100 kilohertz because it uses dividers and couplers that only work at higher frequencies. I did build a clone of the HP, I forget the number, low frequency test set, which lives in here, and it's purely resistive, which means in theory it can work all the way down to DC. In impedance mode, There's a couple nifty things you can do. Config, what do you want? Yeah, so you can pick what you want to plot, and let's say you're measuring a capacitor, and you can do some extra things in special function more menu and its equivalent circuit, and it can compute some numbers for you, which is pretty nice.